Hello, welcome to the session. In this session, we like to discuss about a solution of a differential equation. What is actually a solution? We know about previously you have studied many types of equations are there, a linear equation and quadratic equation, and you solve these all equations are here. Everywhere in every equation there should exist a variables are there. Actually the solution is to find out the value of variables that is satisfies the corresponding equations. But in case of differential equation, we have two variables are there. One is the dependent variable as well as second is the independent variable. The independent variable is the x, and as well as mostly we are treating that as x, and the dependent variable is y, and y is a function in x. Because of y is a function in x, we can say that that should be always a graph or a curve in a plane, xy plane. So, always the solution of a differential equation is a graph or curve in the plane. That is why that is a function. The solution is always a function. There are many methods to solve many ordered differential equations are there. There are many methods to solve a that all the differential equation, and nowadays many softwares are also using to solve such a differential equation such as Mathematica and MATLAB is there for the research purpose. But our interest is to just introduce about first order differential equation ODE. We categorize this ODE into two, that is first order ODE, and as well as second order ODE, ordinary differential equation. We can have many ODEs. As we said, if the equation involves d cube y by dx cube, maybe it can have a third order ordinary differential equation. But in our sessions, we focus on these two, first order as well as second order ordinary differential equation. We focus on first order ODE. So, first order ODE is nothing, as we said earlier, it is the differential equation involves only the first order derivative, and it is the maximum order, it have the maximum order derivatives the only dy by dx. Simply we can say that dy by dx equal to c. Suppose this is also a differential equation, because it is an equation containing the derivative, and its highest derivative is the dy by dx whose order is 1. That is why this is the first order ODE. Our aim is to solve this first order ODE. Solving first order ODE, maybe in some cases it is a tedious work, but even though we are categorizing, we can group differential equations with their peculiarities, with their properties, and with their some special aspects. Based on that, we can solve, we have method to solve a differential equation. Before going to tell about the method of differential equation, I like to discuss about a solution of first order ODE. What about the solution of first order ODE? Not only first order, you can have second order as well as the nth order, the general ODE, See, I like to write about dy by dx equal to c. I am taking this dx to be here. What will happen? Dy is equal to c dx. Integrating both sides. What will happen? Integral of dy is equal to integral of c dx. That is equal to, what will happen is that integral of dy is equal to y is equal to integral of c dx. C is a constant, therefore this is cx plus constant of integration. I like to write it as c1. Now, see, I can say that y is equal to Cx is a solution of this differential equation star, solution of star. How can I say this is a solution of this differential equation star? See, our solution is y is equal to Cx. I like to differentiate this solution. What will happen? Derivative of y, dy by dx, derivative of Cx, that is for derivative of x is 1, Cx, since c is a constant, dy by dx equal to c. So, what is the meaning? This function I told you earlier, y is equal to f of x, am I right? Y is equal to f of x, y is a function in x and y is dependent variable as well as x is independent variable, y can stand with the help of x. So, Cx is a function. While differentiating this function, dy by dx equal to c. So, that is actually this differential equation. What is the meaning? The function y is equal to Cx satisfies the equation star, am I right? This satisfies the equation star. So, the equation star is a first order ordinary differential equation. So, see, we can come back to the solution of a differential equation. So, what is in general? I can say that I am rewriting the general pattern of nth order ODE. What about nth order ODE? The nth order ODE is a expression which involves x, y, y dash, y double dash, etc. The nth derivative of y, that is equal to 0. A function y is equal to h of x. I am write this as a equation number 1. The y is equal to h of x. Y is equal to h of x is a solution of 1. What is the meaning? Which should satisfy the equation 1. How can we say that which satisfies the equation 1? The equation 1 make it is true by supposing y as h of x. So, we can write this, instead of this we can write this as a f of, that is it's a solution if is a solution of equation 1 if instead of x we replace x as x, y as h of x or y itself, and y dash as a h dash of x, and y double dash as a h double dash of x, etc. y n as nth derivative of the function h, which will be also equal to 0. So, the meaning is that the function h of x satisfies the equation 1. So, in general we can say that any function y is equal to f of x or h of x is a solution of an ODE, if it satisfies the corresponding differential equation. Similarly, I like to show with an example. Consider a differential equation dy by dx equal to 1 that we showed earlier, and dy by dx equal to 1 we can take this is to be here, and therefore dy by dy is equal to dx, 1 into dx. Integrating both sides, integral of dy is equal to integral of dx. That is, integral of dy means y, and this is equal to integral of dx equal to x plus a constant of integration, and y is equal to x plus c is a solution. You can write this is y, instead of y differentiate both sides, you can differentiate this solution on both sides. What will happen? Dy by dx equal to derivative of x is 1 and derivative of c equal to 0. Therefore, dy by dx equal to 1. This is nothing, this is the differential equation that we started as a question. So, that is why we can say that y is equal to x plus c, y is equal to x plus c satisfies this differential equation. Therefore, y is equal to x plus c is a solution. See how many solutions can exist for this differential equation. How many solutions can exist for this differential equation? This is instead of c, I like to say this c, make this c as a arbitrary constant, arbitrary constant. So, what is arbitrary constant? The constant that is treating like a variable. It has an ability to vary, it can take different values. So, because of this is an arbitrary constant, you can make instead of c 1, 2, 3 etc. you can have any values. So, what is the meaning? What is the meaning? See, you can have many solutions for this differential equation. From the early standards, we know that y is equal to x plus c is an equation of a straight line. That is an equation of a straight line with a slope 1 and passing through the y intercept c. So, if c equal to 0, what will happen? That is a straight line with the slope 1 passing through the origin. This is the y is equal to x. This is also a solution of this differential equation. And as well as we have, if you have taking this 1, if c is equal to 1, y is equal to x plus 1, y is equal to x plus 1 means is a straight line passing through the y intercept as 1 and which is parallel to the line and which is parallel to this line. This is equal to y is equal to x plus 1. This is also a solution of this differential equation. And as well as you can have minus 1, that is also a straight line passing through minus 1 which is parallel to these 3 lines. This is equal to y is equal to x minus 1. Similarly, you can go to 2. What will happen? This is a straight line passing through 2 as a y intercept parallel to this line because slope is same. Therefore, this is y is equal to x plus 2. This is a line. And you can have any value for y intercept y axis as a for c, because this is an arbitrary constant. You will have a many solution for it. Have a set of solutions. These set of solutions are all the solution. That is why we have. What about the order of this differential equation? This is the first order ODE. This is the first order ordinary differential equation. And because how many arbitrary constants are exist here? One arbitrary constant is exist here. If an solution containing one arbitrary constant for first order ODE, this is what is called the general solution. This is what is called the general solution of given ODE with arbitrary constants. While giving a particular value for C, we can say that that is a particular solution. By giving a particular value for C, we can say that that is a particular solution. That means here C, y is equal to x plus 2. For C, we have given a particular value 2. Therefore, this is a particular solution of this differential equation. Y is equal to x minus 1. This is also a particular solution of this differential equation. So, I like to make one more definition to you, that is the initial value problem. Before going to define that initial value problem, I like to make this as a dy by dx equal to 1 that we discussed in this example, and as well as with one condition y of 0 equal to 2. This is what is called the initial condition. This is what is called the initial condition. And see, we know that while solving this differential equation, we will get solution, general solution, the general solution of this differential equation. The general solution of this differential equation is y is equal to x plus c. And we have given that an initial condition. The initial condition is y of 0 equal to 2. That is, when x is equal to 0, when x is equal to 0, the value of y is equal to 2. Y is equal to 2. We can replace these values to be here in the solution. Therefore, solution changes to y is equal to 2 when the value of x is equal to 0, 2 equal to 0 plus c. So, therefore, we have got c is equal to 2. C is equal to 2. So, we have the solution of this equation dy by dx equal to 1 with an initial condition y of 0 equal to 2. Now, we have a solution, we have got a particular value for c. So, we have a general, instead of general solution, we have solution of, I am taking these 2 as equation number 1, including dy by dx equal to 1 and y of 0 equal to 2. So, this is equal to, we can say that the solution y is equal to x plus 2 is a solution of 1, is a solution of 1. Who is 1? 1 is the, including the differential equation dy by dx equal to 1 and y of 0 equal to 2. So, that we can say that this differential equation which involves the differential equation plus an initial condition, that is what is called the initial value problem. A differential equation containing with an initial condition, such problems, differential equations are called initial value problem. While solving the initial value problem, you will get a general solution first. Then by applying the initial condition, you will have a particular solution. So, in general, we can write a first order ODE by first order ODE. Again, I coming back, a first order ODE y dash is equal to f of x y. Means the dy by dx is a equal to some functions in both x and y. And as well as if I write includes y dash is equal to f of x y with a condition y of x naught equal to y naught. That means this is what is called the initial condition. The initial condition means y of x naught equal to y naught, means x naught is the initial value for x, x changes to x naught, on that time the value of change y changes to y naught. This total will call the general form of first order initial value problem. While solving this, definitely you will get a general solution. From that general solution, by applying this initial condition, you can find out an initial a particular solution. See, there are many methods to find. First order differential equation. That is, first one is the some first order differential equation is of the format of separable equation, and as well as there is a differential equation, that is linear differential equation, linear differential equation. And third one is exact differential equation. These are all the some formats of first order ODE. These are the classes of different types of differential equation. That is, on that classes we have a particular way to solve such a differential equations. Our aim about a differential equation is that to solve a differential equation. That is actually we need to find out the value of y. Is nothing, that is the value of y. Always it will be an expression in x, that is y. That y is a function in x which will be a solution, and as well as the solution is a curve in xy plane. That solution should be a curve in xy plane. That should be a curve in xy plane, and as well as we can have, while treating general solution, you will have a set of curves, a bunch of curves that can be found in xy plane. If it is initial value problem, you can have a particular curve from that all the general solution is a particular solution for this. So, our aim is to solve a differential equation ODE. We discussed here in this session is that what is the solution of ODE? Solution of ODE. A solution of ODE is the all functions of the form of h of x which satisfies the corresponding ordinary differential equation. And as well as here we discussed what is the general form of ODE and as well as the initial value problem. The initial value problem is the first order initial value problem is an ordinary differential equation with an initial condition. It's a initial value problem is a ODE plus an initial condition. So, we can solve while solving a solution for a differential equation, always we have arising a general solution. While solving a differential equation, always we have arising a general solution. And while solving an initial value problem, we will get a general solution, and as well as we can find a particular solution. We can find a particular solution. In all the discussions, this both will exist. Many cases the general solution we are always finding. In some cases, if it is an initial value problem, we will find a corresponding particular solution. Okay. Now, we can discuss about a separable equation. We have the first order ODE, y dash is equal to f of x y, when we can say that this ODE is separable. That is, if f of x y can be written as a functions like h of x into g of y. That is, h of x is a function of x alone, g of y is a function of y alone, then we can say that if this equation y dash is equal to f of x y is a separable differential equation. We can say that this is a separable differential equation. That is why one we can write as one becomes y dash is equal to, instead of f of x y we can write h of x into g of y, h of x into g of y. That is, we can take this is equal to, instead of dy y dash we can write dy by dx. That dy by dx equal to h of x into g of y. I like to bring this dx to here and this gy to here. So we can write this as a dy divided by gy equal to hx into dx. Now, 1 by g of y is a function in y, and into dy, h of x is a function in x into dx. This part is in y alone, and this part has only x alone. Therefore, we are able to integrate both sides. So, by integrating both sides, we will have integral of dy divided by g of y is equal to integral of h of x into dx, and plus 1 c will come, that is the arbitrary constant, is nothing, that is the constant of integration. The c is the constant of integration. So, this is will be the, from this we can find the solution of separable differential equation. We can find the solution of the separable differential equation. See, I like to write some examples for you. Example, dy by dx equal to 1 plus y square. Here see, here is the 1 plus y square is a function of y alone, and here we have dy as well as dx is here. That is why I like to take a 1 plus y square to here. Therefore, dy divided by 1 plus y square is equal to, I am taking this dx to be here, equal to dx. And now dy by 1 plus y square. 1 by 1 plus y square is a function in y, and this is 1 into dx, integrating both sides. So, integral of dy divided by 1 plus y square is equal to integral of dx. Therefore, integral of dy divided by 1 plus y square, we know that derivative integral of 1 by 1 plus x square dx equal to tan inverse of x. Instead of x we have y is here, dy by 1 plus y square. This is equal to tan inverse of y is equal to, this is integral dx, that is x, plus a constant of integration is there. And to avoid this tan inverse of y, we have to get y is equal to. So, we can take that tan inverse to be here, the tan inverse will go on, it is equal to, y is equal to tan of x plus c, tan of x plus c. Therefore, this is the solution of this differential equation. Can go for another example. Example, 10 y dash plus 3x equal to 0. That is, we can write this as a 10 y dash plus 3x equal to 0. This is equal to 10y dy by dx plus 3x equal to 0. We can take this 3x to be here. Therefore, this is equal to 10y into dy by dx equal to minus 3x, and sorry, 10y is here, and we can write this is equal to 10y into dy is equal to minus 3x dx, integrating both sides, So, we will have 10y, 10 is constant, and this is equal to integral of 10y dy is equal to integral of minus 3x dx equal to 10y, 10 is constant, and this can be written as integral of 10y is equal to y square by 2, that is equal to integral of minus 3x, that is equal to minus 3x square by 2 plus a constant of integration c is equal to 5 y square and is equal to minus 3x square by 2 plus c. Maybe we can write, we can take this 5 to be here, and that is y square is equal to minus 3x square divided by 10 plus c divided by 5. This can be written as y square equal to minus 3x square by 10 minus 3 by 10x square plus some other c dash, where c dash is equal to c by 5. This is a solution, and to get y, maybe if we need, we can write this as a taking square root of minus 3 by 10 x square plus c dash. See, dear friends, in this session we discussed about the solution of a first order ODE. So, what is solution? For any differential equation, we can have a solution as a function y is equal to h of x is a solution if it satisfies the corresponding differential equation. As well as in case of first order differential equation, y dash is equal to f of x y, we are treating as a first order differential equation. With the initial condition y of x naught equal to y naught, y of x naught equal to y naught. This is what is the initial condition. This is first order initial differential equation, ordinary differential equation with the initial condition y of x naught equal to y naught. Therefore, we can say that this is a first order ODE. While solving a differential equation, we will get a general solution. In that general solution, that should contains an arbitrary constant c. That arbitrary constant c, like a variable, it can have any values. So, general solution are the set of curves in the plane, and as well as while giving the initial condition, from that general solution we will get a particular solution for the differential equation. And the here we discussed there are three more methods of solving first order differential equation. That is separable variable separable equation, that is separable differential equation, and linear differential equation, and exact differential equation. Here in this session we discussed about the separable differential equation. Actually, the separable differential equation is those differential equation in which this function f of x y can be separated as a function in x and y. If f of x y can be separated as g of x into h of y, where g of x is a function of x alone and h of y is a function of y alone, then we can say that this is a separable differential equation, and that separable differential equation we can solve by using, that is y dash is equal to g of x into h of y. This can be written as y dash can be written as dy by dx equal to g of x into h of y, and we can take that h of y to be here, that is dy by h of y. Dy by h of y is equal to g of x into dx. By integrating this on both sides, we will get a solution of differential equation as integral of dy by h of y is equal to integral of g of x into dx plus c. So, these two examples shown that how to solve a separable differential equation, and try to solve with more examples. Thank you for watching these videos. Thank you very much.